So welcome everyone to today's EWTS session around design and visualization for enterprise XR applications. I am the moderator. My name is Nathan Yorgey, and I have with me today a very capable set of gentlemen who are going to join me and really provide you some interesting answers and thoughtful information around using XR technology for design and visualization. So I'll introduce myself to begin with, and then Drew, Ryan, and Benjamin will introduce themselves, and then we'll get into the meat of the session. So as I said before, my name is Nathan Yorgey. I manage a company called CyberTwin, LLC. So what we do at CyberTwin is we develop digital twins, and then we use those digital twins for spatial computing purposes. We also leverage XR technology, of course, because when you're doing spatial computing, it works best when you're using either VR, AR, or some type of mixed reality. And so what my company does is we provide clients, many like yourselves that are coming to listen to us today, with digital twin services, and then also with XR services for operational value, for training, and then for any type of visualization purpose beyond those kind of using it for operational value or ML, AI, or training as well. So that's a little bit about me. At least on my screen from left to right, Drew, I see you first. So could you give a short introduction? And as you're doing your introduction, also give a little bit about how you use XR technology in your day-to-day life, please.
Absolutely. Thank you, Nathan. Drew Holbrook. I manage the Extended Realities Group at Gulfstream Aerospace. I've been at the company for over 16 years now. Spent a large portion of my time in the engineering world, and around 2015 was introduced to augmented virtual reality. We started a group internally, and since then we started picking up different applications all across the company, ranging from engineering to manufacturing to customer support and marketing. We focus on augmented and virtual applications heavily. We use the game engines to do that. We also look at other advanced technologies, like there's some AI and ML dabbling in there, and some of the other features that are coming on with the Industry 4.0 initiative. So in our group, it's every day focusing on something augmented or virtual. We just released one of our first augmented reality production applications just a month ago. So that's our focus, and hoping to expand our use cases as we move along.
Thank you, Drew. Ryan, go ahead, please.
Thanks for that, Nate. So my name is Ryan Roper. I'm a senior project engineer with BP. I've been working on a major offshore gas compression facility for the past couple of years. And my experience with AR, augmented reality, has been as a package manager responsible for bringing the engineering, procurement, and construction of major pieces of equipment from all over the world to one particular site. And as you can imagine, the alignment and the dimensional analysis of each piece of equipment from each vendor is really key in getting them all put together in one site. Currently, I'm one of the project leaders for the offshore hookup and commissioning scope for that same offshore gas compression facility. And now we're really testing whether or not we are achieving our goal, our primary goal, of having installation done right the first time.
Excellent. Thank you, Ryan. And Benjamin?
Hi, everyone. I'm Benjamin Nuernberger. I work at NASA JPL. I'm the technical lead of a software project called Protospace. It's a collaborative CAD visualization tool that runs on the web as well as HoloLens. And it's great working at JPL since we build spacecraft, scientific instruments, robots. You probably heard earlier this year, we landed Mars rover and helicopter on Mars. There's Earth orbiting satellites, and also spacecraft that go out into other parts of space. And it's great because we work with a variety of end users directly, from engineers and scientists, and sometimes occasionally astronauts as well. I first got into XR technologies while in grad school at UC Santa Barbara. I did a thesis on mixed reality remote collaboration in an interdisciplinary lab called the 4 Eyes Lab, standing for the 4 Eyes of imaging, interaction, and innovative interfaces. kind of a mixture of like computer vision, media arts technology, AR, VR, et cetera. So it's been great working in this space and looking forward to the panel today.
So I've got to say, gentlemen, I'm honored to be the moderator of this panel because there's clearly a lot of smart people in the room, from putting airplanes in the sky to figuring how to extract oil from oil wells. And then Benjamin, you know, what you were doing at NASA, we're putting people in space. So I think for the audience that's listening and for those that are participating, there's a lot of good knowledge that's locked in the head of these three gentlemen. And so as we go through the session, I think you'll hear that varied kind of view of the challenges that one has when you're trying to create luxury aircraft, to the challenges that you face when you're trying to put vehicles or people in space, or some of the more kind of remote challenges that you face when you're trying to operate XR technology on an oil rig, or with people who are in kind of that very demanding space trying to do work. It runs the gamut. So I'm hoping that you'll hear, you know, maybe you're not in one of those three industries, but probably your use case can relate to something that these three gentlemen experience every day. So because this session has been recorded, if you're still with us, I figure let's tell you up front what we're hoping you're going to get out of the session. And then as we go through the session, I'm hoping that you'll be able to track and see how we laid out each goal and how we then kind of talk about it. So the goals that we're hoping you're going to get out of this session are, you'll get some kind of a window into how XR technology can improve and speed up the design processes while reducing cost and risk. Another one is, how can XR improve stakeholder communication and prevent rework? The third one is around simulations and how we can use simulations for planning layouts, assembly builds, product iterations, and how really XR technology can be optimized through simulations and how simulations are used. The fourth one is around digital twins and trying to really understand, how are digital twins such a valuable tool, and how does XR technology really take digital twins to the next level? And then finally, how XR technology allows for 3D asset visualization and enhanced learning. So there's some real meat that we want to get to here. So let's jump right in. And Ben, I'm going to turn to you with our first question. The first question is, can you explain how XR technology has helped your company with design and build projects? And then describe some of the value proposition that has come through XR tech for design and build.
Sure. Yeah. So at NASA JPL, we've been using XR in various ways, even before I joined about 4 years ago. There was a big push made when HoloLens first came out from Microsoft, and we developed two applications back then. One was a walking on Mars application, visualizing Mars terrain. That was called OnSite. Another one was with astronaut Scott Kelly, doing a remote collaboration from mission control up into outer space in that domain. And that project actually eventually turned into the project I'm working on today called Protospace, that again is a collaborative CAD visualization tool. And actually we've seen usage all throughout the entire mission lifecycle. So, you know, in developing the missions, someone has to propose it, talk about the science questions, but also make sure it's technologically feasible, and can you actually build the spacecraft or the instrument or the robot. So even from the proposal stage, being able to visualize something of a spatial nature, such as a spacecraft, a CAD model, is really important. It helps communicate with the stakeholders, discuss the design decisions. And even after that proposal stage, when you're getting into those design reviews and making sure the design is right, we've had anecdotes where people come in and use the technology after months of emails back and forth. And you know, they're trying to figure something out, and then they put on the headset right away, and then they got the answer almost right away. Another anecdote is with the Europa Clipper project, we had some engineers rehearse the procedure early on in the design phase because they know they have to eventually build the spacecraft. And they figured out that actually it's not going to be that easy to assemble it in the way they designed it. So they actually altered the design to reduce risk further down in the life cycle. Which is, you know, when they assemble it, when they integrate all the different subsystems, which is another use case that we've seen as well. Even just interacting with the facilities where you're going to assemble this in the clean rooms, ground support equipment, testing, will these things work? It saves time, it saves money. So that's really the big value proposition for us. Saving time, saving money, reducing risk, helping that communication. Because at the end of the day, it's not just a toy or something that's really cool to play with or demo. For sure, there is that aspect, and it helps get the point across to people. But at the end of the day, it is a communication tool, collaborative in nature, that allows people to talk about these inherently spatial things using these stereoscopic headsets such as the HoloLens. And in some cases, it saves rework and saves a lot of money. So it's been really great just to participate in the process.
Yeah, you as you were ending there, you were talking about how a lot of the design work that you do, it really is spatially oriented, right? Like you're having to visualize things, and I was hearing you talk about how XR technology allows, really brings that doing things in space and interacting with them in a way that you just can't get if you're not using an XR headset. So I want to turn to both Ryan and Drew now. Are anything else as you think about your own industries that you would want to add to what Ben said, about how NASA's using it? Anything else you'd like to add?
Say from a Gulfstream standpoint, Benjamin nailed it on the head. Being able to visualize those models. So CAD's 3D data, but it's still on a 2D screen. Being able to take that and show it in space, in a spatial area, makes a huge difference, especially and like you said, from the design all the way through manufacturing. And then you can take that single model at the early design phases, help improve the design, and then even when you get to manufacturing, using that same model to visualize from a production standpoint has a tremendous impact on the ability all the way down the pipeline.
Yeah, and there's not much more I can add other than for offshore facilities, we often we really need to utilize our space very effectively because we don't have much space offshore. And so we talked about that spatial view, and just like Drew just mentioned, a two-dimensional view on a screen is quite difficult sometimes, where we need to optimize the space that we've got available and the processes that we need to have occur offshore on limited real estate.
Yeah, I can think of one real quick example from my days before I joined CyberTwin. I worked for Pfizer Pharmaceutical Company, and we used XR technology when we were doing new design and build of facilities. And there's one particular example that just sticks in my mind where we put a headset on a couple of individuals at a plant, and they were looking at, they were bringing those two-dimensional AutoCAD drawings of the facility to life. And when they were moving around this proposed space, there was this pipe that just ran out into the middle of the room underneath the conference table that was going to be in the room. And they're like, whoa, where did this come from? And then when they went back and looked at the two-dimensional drawing, it was there, but you couldn't see it in 2D. It didn't pop out at you the way that it popped out when you were looking at it in 3D. And so, while that's a simple example, and they could easily, put that was supposed to be under the floor, not in the room. So it was a simple fix. If they had not caught it in that stage, the amount of rework that would have caused, because then there would have, they would have been building, and then, okay, we got to go back, we got to get a new plan. And now you're seeing it, and you're cutting it off before it gets to the phase where people are physically trying to put that into space and then have to realize, whoa, this can't go there. It's not going to work. So I think you the three of you elaborated that well. So Ryan, I'm going to turn to you next. And now we're going to talk about, how XR technology can really help prevent rework. So talk about how XR technology either directly or indirectly prevented rework in your job. That's the first part of the question. And then the second part is, I'm curious, does XR technology really improve stakeholder communication?
All right, yeah, thanks for that, Nate. With XR, we've been able to save time, we've been able to improve safety and prevent rework. Again, like I said, our quest really is to ensure that these massive pieces of equipment are installed right the first time so that we don't have that rework. Because we utilize the HoloLens at the vendor shops primarily, the fabricators' shops, our engineers, our technicians, they were able to see what our inspectors see during inspections and factory acceptance tests, for example. This question reminds me of one particular incident when one of my technicians put on the HoloLens. He was able to walk through one of the packages, and very quickly he was able to see that a flywheel was positioned too closely to an upright, thereby creating a potential pinch point. Again, as Drew said earlier, it can be quite difficult to see these sorts of pinch points on a 2D screen or in 2D. And in 3D, we were able to really see that. And within 10 minutes of the observation being made by my technician, I was able to get the modeler together with the welder and the fabricator and my engineers. And we were able to spot the issue on the model and put an action in place to eliminate the risk of that pinch point. And that was done in the fabricator's shop within 10 minutes. One thing I'd like to add here as well is that if we had missed that at the fabricator's shop and it had gone all the way offshore, one offshore man hour is potentially 3 times as costly, both from a financial perspective and schedule, as an onshore man hour, right? So the fact that we were able to spot that in the fabrication shop, all of the tools, the right people were already in the room, that change could be made really quickly. One other point I'll make from a stakeholder communication perspective is that really XR has allowed a wider audience to view these inspections and factory acceptance tests based on the remote monitoring capability that the HoloLens brought with it. So we were able to, through MS Teams, request from the office, the engineers could say to the inspector, could you look at this point of concern? And he would be able to look at it in real time while the engineers observed from the office or even from their homes, right? So that was a really good way of expanding the access to the teams. Additionally, the inspector was able to take snapshots, pictures, and even videos of these factory acceptance tests, these inspections. And now I have a database full of recordings that I can show to younger engineers, younger and less experienced inspectors, and they can learn in the office or from their homes once again, and really learn how to add value when they get out into the field.
Yeah, it's interesting when you talk about kind of that remote collaboration feature. Who would have thought, that's a valuable feature before COVID, but now with COVID in the world kind of struggling and wrestling with that. I mean, the fact that we're here recording, this today, everyone is embracing remote collaboration in some form. But I think what you call out there with that ability for people who are remote to be able to see and get value from those remote inspections just enables BP to continue to do work in a way where you're not skipping a beat, you're not struggling to do it, you're just using XR technology, and that's a real enabler. So thank you for sharing that. That second point, and you may have already addressed it a little bit, but if you could elaborate a little bit around how XR technology has improved stakeholder communication, or maybe it hasn't. It seems like it has from even that remote collaboration example you gave, but could you tease a little bit more how XR has helped stakeholder communication at BP?
Yeah, so for example, with the flywheel option, flywheel observation, usually that would require a report that then would be circulated to another group of people. And it could take maybe a day or as much as a week sometimes if we had to go through a process of reporting, etc. So in terms of that communication and us being able to very quickly see on the 3D, on the HoloLens, the issue, that created that 10-minute sort of turnaround. In other ways, from a stakeholder communication perspective, one way that we saved money really is that to attend these factory acceptance tests, usually there's a bit of a fight, right? So people want to go to factory acceptance tests to get that experience. So from a stakeholder communication perspective, we can now have this wider audience see in real time what's happening at the factory tests, so that we don't now have to create these reports that then circulate for squad check and review and endorsement, when everybody can now access the recording and see it much more quickly and record, report, and make modifications at a much faster pace.
Oh, that's excellent. So Ben and Drew, any other insights that you'd like to add from your own perspectives?
I could add another quick anecdote, which is in terms of rework. We had one group that was planning to set up their equipment in a certain way, but then when they used the HoloLens, they realized that setting it up that way would require someone to work under a suspended load, which is not correct, and you can't do that with OSHA requirements. So, you know, that saved like a day of rework, for example. In terms of stakeholder communication, one thing we've realized is, you know, just engaging with that medium of immersion is so valuable, especially with things that are full scale, you know, for spacecraft or things that are large in nature. It really helps people appreciate the full scale of it. But in addition to that, you know, stakeholders could be managers, but it also could be subsystem owners or integration engineers. It helps people get onto the same page faster, just due to the nature of the stereoscopic displays and XR technologies.
Yeah, I can say from Gulfstream standpoint, using the XR technologies, we had one use case to where the design team, all of our models are in 3D CAD, so it's already there, but they had went through a design and we put it in VR. And it wasn't until we got it in the VR that we actually realized that there was some clashes going on in one of our galleys and had to do a redesign. Now that being done in production would be a lot of money to rework that. So being able to see it up front in the VR simulation was really helpful. As far as communication with stakeholders, what we have found is like in the past, you used to sit around conference room tables and it was always kind of tense because everybody had their pecking order. But if you bring that same group into a room with a VR headset or a HoloLens or multiple, the atmosphere changes. The communication, they start talking to one another a lot more, and there's a lot of side conversations. They all start, it kind of levels. Managers and your SMEs are all starting to throw out ideas and share in the less rigid structure of the conference room. So it's really opened that up from our standpoint.
Yeah, that's a fascinating you know, point that you make, Drew, because I've seen the same thing in many different arenas where it feels like XR technology is that single point of making the playing field level. And whether it just makes everybody equally vulnerable, or whether it just removes, I haven't been able to put my finger on exactly what's the root cause of how it creates that environment, but it definitely does. So if you're listening and you're maybe there's some either management resistance to XR technology, or you're just questioning, is this really going to help or is it going to detract? I think you've just heard a loud and clear from these three gentlemen that there's a value here that is almost intangible, that once you get it and you start to use it, you're going to see communication happen in ways that maybe you were struggling with before internally, because it just is this natural, it draws people in, and then it creates space for communication. So thanks for the three of you. All of those were great answers. So Drew, I'm going to turn to you next, and we're going to talk about simulations. So, you know, if you spend any time on Google and you start putting in the terms XR and simulation, there's a lot of information you're going to get back. So I'm curious, is Gulfstream using XR technology for simulation purposes? And if you are, can you talk about some of the use cases and the benefits?
Yeah, we are using it. We're utilizing. So one of our simulations, like on the engineering side, they have the tools and the methods that are required to get the precision that they need. But a lot of times, whenever it comes to showcasing what that is, for example, computational fluid dynamics, so the airflow over the aircraft and how it performs and things like that. It's a lot of science, and in order to present that information, you show a lot of graphs and a lot of charts, and it can become very cumbersome if you don't have a master's degree or PhD in it, and even sometimes it can be crazy to see. And then you can simulate it in wind tunnels, but those are costly. So what we've been able to do is take like post-processed CFD data and put it into the HoloLens. And on full scale, we've been able to simulate what airflow looks like over the aircraft. Then we can take and show it to not only SMEs, but your managers and upper management. And then they can see, sometimes for the first time, like what's really happening in the simulation and get a better understanding. And being able to visualize things that are typically hidden, like water flow through pipes and tubes, and show it in a simulation can change how people think about what the decisions they're having to make from a management standpoint. So from the simulation side, we use it as much as we can. It takes another level of training and skill set, because just taking 2D models in 3D is fairly straightforward. Adding that animation and that simulation to it takes a little bit more effort and expertise. So it is a little bit more challenging, but once you get it, the impacts are invaluable from that standpoint.
Do you build these models in-house, or do you outsource it to third-party solutions?
So we're doing it in-house. We're learning and becoming game designers as much as engineer IT professionals as we go. And it's been great, because what we're doing in-house, a lot of the companies we work with, like the game engine companies, they're very supportive in knowing, okay, you're not a designer in this field, so we'll break it down and make it simple and easy for you. But there are plenty of tools and platforms out there that'll do it for you. If you just look around enough, you can find whatever you want.
Excellent. So Ryan, I can imagine on an oil rig, there's a lot of potential value for simulations. And so can you talk briefly about how BP and what you're doing to kind of use simulations and change the way that BP works?
Yeah, so we are really getting into digital twinning and trying to utilize the data that we have with the digital twin to understand better our maintenance strategies, our maintenance schedules. What can we do to understand better how we work with our vendors and simulating how valves work, how the environment, or the offshore environment or onshore, any remote environment really can potentially impact our equipment to ensure that our equipment then can last as long as possible prior to having to make change outs. Another thing that we're trying to do in terms of simulation is, because our goal is to attempt to remove people from plant, trying to mitigate the risks of people having too much exposure to potential risks just of traveling to site. We're looking at simulations of how a plant will work during a weather event, for example, and understanding how the equipment is impacted by various types of events. We're looking at that from a simulation perspective and using mixed reality to understand how we can better take care of our equipment on an ongoing basis.
Oh, that's great. I can imagine. And as weather becomes more extreme, I think the need for being able to simulate how things are going to operate in extreme conditions is probably a direct $2 value for BP, I would assume. So Ben, I'm sure that NASA does zero simulations. You go directly from design and build to blasting people off into space. No, I'm sure you do lots of simulations. So do you want to share some experience of how XR and simulations is allowing people and product to get into space as safely as possible?
Sure, yeah. For us, we haven't done fluid dynamics simulations in XR. I know other NASA centers have, so that's definitely being used across NASA. But we have done other things like simulate orbits in AR and VR. Another thing kind of related, maybe not exactly simulation, is training or like tribal knowledge transfer, kind of that area. A lot of times people come in and they rehearse or they plan out an assembly procedure, and they get a bunch of different people in one room, and instead of talking it over on a PowerPoint or creating an expensive physical mock-up, if you just don the headset and see it in augmented reality, you know, it's a lot faster. And sometimes I've heard they come in with different groups of people in case, some people get sick and they can't assemble it on time because, they have to launch it into outer space by a certain date. So it's been great to, see them using AR VR in that way as well. We also do some animated, like interactive assembly instructions as well.
No, that's great. I think you all clearly portrayed the value of XR and simulation in the various industries that you work in. So for a minute now, I'm going to take off my moderator hat and talk a little bit about, because we promised that we would explain how digital twins are a valuable tool when combined with XR. And I think each of you in a small way have already talked about, you've mentioned digital twins. And I think when we talk about XR technology and even simulation, it's impossible to not pull in this concept of digital twin. So I'll elaborate a little bit on this, and then gentlemen, I appreciate if you would weigh in with your own perspectives on it as well. So taking my moderator hat off, one of the things that my company does now, CyberTwin, is we will come in and we will create digital twin models. And so we've seen our direct customers extract value from a digital twin and XR technology in a couple of ways. I think one big way, Ben, you talked about, is using that digital twin for training purposes. And whether it's AR and kind of doing that augmented reality view of step-by-step guided instructions in augmented reality overlaid on that digital twin, or where many of our clients have found a lot of value is using VR. And so kind of in that digital twin, creating a VR experience where if it's a series of, pharmaceutical instructions or manufacturing steps, they're actually gaining the muscle memory, moving through and interacting with the operations that they're supposed to do. And while that's happening, they're able, the machine, whether it's a Quest or a Rift or whatever it is that they're using, they're capturing all of the accuracy and precision that they're doing, or in many cases, lack of accuracy and precision. And so as individuals go through this training multiple times, the instructors are able to see the improvement, and they can also set a threshold where before XR came along, it was many times it was an observational. The instructor would watch the individual do it, and if they felt they were close enough to correct, okay, we're going to assign you as being passed, go out and be dangerous. Now we have the ability to see through interactions, through body movement, through even the way that they interact with hooking up pipes or valves or pressure or whatever it is, seeing it happen in real time. So training is a real value. The other way where digital twins and XR technology are valuable, and if I take a step out of my role being a provider of XR technology and think back to my days when I was in a pharmaceutical environment, digital twins were very valuable to us as far as being able to then overlay data. So whether it's sensor information, whether it's other types of machine information, you can put that and anchor it spatially inside a digital twin. And now I have the ability with XR technology to be able to see that spatially over the machine through augmented reality, or even virtual reality if I needed to do that. And so, when I was a consumer of XR technology in my pharmaceutical days, that was extremely valuable, and from an operational standpoint, really drove operational efficiency. Now that I'm offering digital twin technology, we're looking to layer on top of that digital twin machine learning and artificial intelligence. So now we can offer to a maintenance worker the ability to not just say, what is the real-time data on a sensor, but now because we can hook in historical data and then using machine learning and artificial intelligence algorithms, be able to go back and look at the maintenance data over 12, 24, 36 months and come back with insights on this piece of machinery has broken historically every 6 to 7 months. So you're in that 5-month window now. You should, we suggest that you go ahead and take some preventative downtime, fix it before that preventative downtime turns into just-in-time downtime. And so now there's an impact to production scheduling, or an impact to being able to, meet fulfillment on oil or aircraft or whatever it is that you're trying to build. So those are some ways that I experienced in my pharmaceutical career, and now that I'm selling these products, experience of seeing clients be able to leverage digital twins and XR technology. But you gentlemen are the experts here today. So I welcome any of your thoughts elaborating on that fusion of digital twins and XR technology and how it's aiding you in the work that you do.
So I can start here.
Go ahead, Ryan.
Okay. Yeah. So we on this same project, we're working with Solar, a company that provides gas turbine generators and BHGE to do exactly what you're talking about, Nate, in terms of providing insights from remotely at their headquarters about the maintenance strategies, the maintenance requirements, the life of the expected life of these generators, for example, and they're able to look at these maintenance strategies, look at these maintenance requirements of valves within their packages and electronic equipment within their packages, and provide us with the guidance as to whether or not these pieces of equipment or transmitters need to be changed. Previously, what we would do is we would work on at the spreadsheet level, essentially trying to figure out when last did we change this and when should we change it next. And now we're making a real step change with these insights from companies like Solar and BHGE.
Excellent. Drew, you were going to mention something?
Yeah, I was going to say from a digital twin standpoint, I think there's a lot of value in that and how it correlates to XR, because while your engineering may use one program to design whatever it is, your manufacturer is not going to use that same program to view it and put it together. Where digital twin plays the huge role is it creates that single source simulation that can be used throughout, where it starts with engineering and ends with manufacturing, customer support. And then when you tie, I mean, we live in a 3D world, and yeah, while a lot of us are stuck at home with COVID, there's still guys who are or people who are still out in the world putting things together physically and joining it, and then being able to take those models and then put it, like we were talking earlier, in the spatial world that we live in and see things on one-to-one scales. That's the huge impact of tying that digital twin back to XR together in a single place. It really has that a capability of just bringing the 2D to the world we live in.
Ben, any thoughts from your end?
Yeah, the only thing I would add, I think you all nailed it, is just think of the last time you assembled a piece of furniture. If you've ever got an IKEA furniture or whatever, you know, it's pretty difficult to transfer those spatial instructions from a piece of paper into the physical world. So, you know, we've done, you know, quantitative user experiments, a lot of other people have, and, you know, the potential and the benefits are all there. And when you have digital twins, adding XR on top of it, I think really is really valuable.
You hit a hot button, Ben. You must have been to my house, because I have 2 or 3 pieces of IKEA furniture that are not 100% right, because I couldn't understand what they spatially meant.
Exactly.
And so then I was too proud to take it apart. So I'm just like, it was meant to be this way. So that's a great example. So I think, to wrap up, the question that probably everyone who's listening to us is probably asking is, man alive, you guys there's so much value from XR technology, but this is the get real section. Not everything is sunshine and roses, right? Like in each of your implementations of using XR technology for a specific purpose, I'm sure you've encountered bumps along the road, and, you know, design and visualization are all enabled by XR, but they can probably also be disabled to some degree if the technology doesn't work, if Wi-Fi isn't available, if it can't reach the audience. So if we're now speaking to somebody who's just starting out exploring the value and use cases for XR technology, what valuable pieces of information would you like to impart to somebody, maybe even your former self when you were starting out in this journey? What information would you tell today's self that would help, you know, that you'd love to know if you were just starting out? What would have helped you if you're here for the first time trying to figure out this whole XR game as it relates to design and visualization? What should these people know? and I'll open it up. So whoever wants to talk first.
I guess I'll start off. I can say a couple things. One, IT will become your friends. They can make or break it, and you don't want them on your bad side, because especially your security team, you're going to be bringing in a lot of new technology and a lot of new hardware that takes time, and you need the infrastructure. You mentioned Wi-Fi capabilities. There's sometimes where you might not have that capability, so you have to be able to understand the limitations of the technology, the hardware and the software in these use cases. The other one is patience. It's not going to be quick. You might be able to think you can get something set up in 6 months, but whenever you start digging into it, you realize it becomes a lot longer of a haul. I mean, it's taken us 6 years to get to where we are. And so I would say always be ambitious, because it can happen, but definitely be patient in trying to pursue it.
Yeah, wise words, very wise words.
I would jump on that piece on patience as well, in terms of management of change and really understanding who your stakeholders are and who are going to be your friends in terms of trying to progress this throughout the organization, especially a larger organization. I think that was, for me, a major concern or challenge. And then also patience, again, with regard to rolling out how these gestures are made, for example, on the HoloLens 1, and getting your team to really buy in to utilizing this new technology.
Yeah, Ryan, that change management, you emphasized it, but I want to re-emphasize it. You cannot underestimate the change management curve, and finding change agents inside an organization or inside a project that can help you champion the use of XR technology. In my own experience, and Ryan, it sounds like that's what you were talking about, finding those change agents and then making sure that you have a solid change management plan is a real key to success. So great point. Ben, any insight from your standpoint?
I was going to say the same thing, find champions and be patient, because those champions, they might have opportunities for you at a certain time or not. And patience both in teaching people certain hand gestures, also patience in finding those opportunities, like as Drew mentioned. The other thing I thought of is always be user-centric, because the technology can do a lot of things, but you have to really have that conversation with your end user to make sure they understand what it can and cannot do. And to make sure this XR technology is really what they want or need. In many cases it is, but in some cases it's not, and they'll appreciate you being upfront with them about that. And that could open the door for other opportunities where it does make sense down the road.
Exactly. So one insight from my own experience is making sure from the start of the project that you have a clear return on investment and goal that you're shooting for. I have watched other peers of mine in companies try to adopt XR technology into a project because they thought it would add sex appeal and sizzle to the project. And it fell flat because it could have been valuable, but they didn't articulate from the beginning what value is XR bringing to this project, or to even our company, if you're thinking about it broader. So because there is a change curve, don't start off by assuming everyone's going to see maybe what you view as a very apparent value from XR. Clearly delineate it, clearly say it. And then once you do that, you at least are setting yourself up and your project team up for as much success as you can have, assuming you're going to have bumps in the road. Well, we're almost to the end of our time here. So I want to thank each of you gentlemen for being a part of this panel, for giving of your time today, for sharing your valuable insights. For the audience members that are listening here, hit these three guys up. You've got the entire month, or almost the entire month of October, to have access to the panel. These guys have a lot of knowledge locked in their heads of both good, bad, ugly, and bumps along the road that they've had in their experiences. So make sure that you connect with them through the portal, ask them questions, pick their brains. I've been to EWS now for a few years, and that's part of what I find to be so valuable about the whole experience, is rubbing shoulder to shoulder with other people who are in the trenches doing what you're trying to do and getting real world experience. It's not just the head of Microsoft saying you should use spatial computing. It's actually people who do it. So talk to them, and tap into their knowledge. We're now going to move into our live question and answer period. So with that, we'll close and we'll pivot into question and answer. Thanks, everyone.